we will be going over introduction to statistical machine translation and neural models for translation. The first half of the session will be theoretical. Then we will take a 5 minutes break and jump into some coding using Google Colab. So the agenda for today is we will do a recap for week 1 to 3. Then we will learn what machine translation is. I'll go through some brief history of machine translation, what is statistical machine translation and neural machine translation, and the encoder decoder model. And then we will dive into some Google Colab, which will be led by Karen, and we will return back to the slides and do a recap and next steps. So in session 1 and 2, we spoke about the fundamentals of NLP and her high-level introduction. So NLP is a subfield of computer science and artificial intelligence. Rishika and Yashika also spoke about some text processing and data wrangling techniques, some EDA, analyzing and understanding our data, as well as some representation with tokenization, text to sequences, and pairing sequence. And today we will talk about machine translation and models used to build the machine translation systems. Uh, so machine translation is a form of computational linguistics and language engineering that uses software to translate text to speech from one language to another. In short, it's a task of automatically translating from one language to another language, making sure to preserve the meaning of the input text and producing fluent text in the output language. So here's an example of the translation system that many of you might have seen, which is Google Translate. In this case, the translation is from English to Chinese. In the later slides, we'll go through the main steps of building the modern translation system. But before we dive into it, let's talk about some challenges in machine translation system. A well-known problem is ambiguity. So let's take a look at this example here. So you see the word book in English. It has two quite distinct meanings as illustrated by this example. So if you say book the flight, it is a verb and it has one meaning. And if I say read the book, it is a noun and it has quite a different meaning. So for many languages, if we try to translate book into another language, we end up with a very different lexical choices depending on which sense the word book is being used. So if we use book the flight, it has another translation in Spanish. And if we say read the book, it has another translation. So the translation here is going to require us to resolve this lexical ambiguity based on a particular context. Another challenge is that different languages have different word orders. So if we consider the translation to English and Japanese, English is systematically subject, verb, object, and Japanese is subject, object, and verb. So here's a simple example that you can see, but if you start using longer sentences, these kind of word order differences can get really quite complex for different languages. There's another interesting problem where you see syntactic structures not necessarily preserved across translation. Different languages can express concept fundamentally in a very different way. So here we have an English sentence, the bottle floated into the cave. And here's the Spanish translation with the paraphrase of the translation. So the translation is literally the bottle entered the cave floating. So there's not necessarily a direct correspondence between the syntactic structure of these two translations. So these are the few challenges of machine translation systems. Now let's dive into a brief history of machine translation. This will give us a history of approaches that people thought about in a few decades of machine translation. So the rule-based approaches were used in the early days of translation between 1950s to 1980s. And statistical-based models go back to the early 1990s. There was seminal work by researchers at IBM who developed the first statistical translation systems. And you'll find these systems form the basis of many state-of-the-art models, including, for example, Google Translate. Um the neural machine translation came around in 2016, and with its faster and accurate translation speed and quality, many companies like Facebook, Microsoft, Google transitioned into using NMT. Now I'll give you all an overview of all the translation approaches. The first one is the classical machine translation, the rule-based. So the rule-based machine translation translation is a translation system based on linguistic information about source and target languages, basically retrieved from dictionaries and grammars, covering the main semantic and syntactic regularities of each language. In this method, the translation process is performed word by word. So if you see this example, each word in the sentence is mapped word by word. For example, cat is mapped to gato and so on. In the rule-based methods, human would try to hand-build translation systems, for example, compiling like bilingual dictionaries specifying how words in one language would translate into words of another language. So it comes with a lot of challenges. It requires like knowledge and relatively expert human labor. It relies on a large bilingual dictionary. So for each word in the source language, the dictionary specifies a set of rules for translating that word. And with so many rules, the system can become very complex. That's when statistical machine translation replaced the classical rule-based systems. So statistical machine translation is a machine translation system where translations are generated on the basis of statistical models whose parameters are derived from the analysis of bilingual text corpora. What this means is statistical machine translation starts with a very large data sets of approved previous translation, which is known as corpus of text, that is when used to automatically deduce a statistical model of translation. The idea here is that phrases that commonly occur will be translated much more accurately. So in this example, you'll see that the phrase "the cat likes to" is a common phrase in the source language. This will be translated much more accurately than they would have if you just did word to word, like how we did in rule-based systems. The few challenges of statistical machine translations were it consumes like a lot of memory and time. As SMT takes previous translation, if the translating material that is not similar to the content from the training corpora, the accuracy fails drastically. So, with the power of deep learning, neural machine translation is the most powerful algorithm to translate text from one language to another. It is a task of converting a sequence of word from a source language like English to a sequence of word to a target language like Spanish or French or Hindi or any other language using deep neural networks. It is designed to mimic how the human brain learns the language. So it's based on the model of neural networks in the human brain, with information being sent to different layers to be processed before output. So the goal of any NMT model is to take the whole sentence in one language as input and return that sentence translated into a different language as output. So the figure here is a naive representation translating the whole sentence from English to Spanish using the neural network. So the most commonly used model to make these translation systems is a sequence-to-sequence model. The sequence-to-sequence model maps a source sequence to a target sequence. So the source sequence is the input language to the machine translation system, and the output sequence is the output language. These models are used for a variety of NLP tasks, such as test summarization, speech recognition, etc. Our aim here is to translate a given sentence from one language to another. A typical sequence to sequence model has two major components, an encoder and a decoder. But before diving into these two components, let's talk about a way to transform these sentences into a data format that the machine can understand. So in essence, we must somehow convert our textual data into a numeric form. To do this in machine learning, each word is transformed into a one-hot encoding vector, which can be inputted into the model. So in the table here, we have assigned a unique index 0 to 6 to every word. And then assigning a unique index to each unique word, a vocabulary for each language is created. And using this vocabulary, we create the one hot encoding vector for every word in our data set. The SOS and the EOS tokens in the table are added to every vocabulary, and they stand for start of the sentence and the end of the sentence. They are used by the NMT model to help identify these crucial points in sentences. Now that we have our mini vocabulary of a data set, we will convert the words for the sentence "the cat likes to putty" to their one hot encoding vectors. Each word becomes a vector of length 7, which is the size of our vocabulary, and consists entirely of 0 except for a 1 at the index that was assigned to the word in the mini vocabulary. So by creating a vocabulary for both input and output languages, we can perform this technique on every sentence in each language to completely transform any corpus of translated sentences into a format suitable for the task of machine translation. Now, with the understanding of how we can represent textual data in a numeric way, let's look at encoder-decoder model. At the most basic level of this model, the encoder portion model takes a sentence in the input language, creates a context vector from the sentence, and this context vector stores the meaning of the sentence and is subsequently passed to the decoder, which outputs the translation of the sentence in the output language. So the encoder reads the input sequence of words from the source language and encodes that information into a real valued vectors, also known as the hidden state or thought vector. This thought vector encodes the meaning of the input sentence into a single vector. The encoder outputs are discarded and only the hidden or the internal states are passed as initial inputs to the decoder. Uh, the decoder works in a similar way to the encoder, but the other way around. It takes the thought or the context vector from the encoder as an input along with the start of the string, that is the SOS token, as the initial input to produce the output sequence. So this concludes the conceptual part of the session. We will take a 5 minutes break, and if you have any questions, please post in the Q&A box. And after the break, Karen will walk you all through the coding part of the session.
All right, hi everyone. Hopefully you guys had a good break, good weekend. Sorry, it's Monday morning here. Thank you, Jasmine, for the very detailed and nice explanation on machine translation, different types of machine translation, specifically on the neural machine translation. So as you guys, if you guys, I know a couple of you just started, this is the first session to join. You feel free to recap all the materials on the GitHub link. I will show you guys where it is. Don't worry. It is very important because natural language processing, everyone talk about it. We know this is something that's less, is from like, it's very useful. It's definitely a very powerful thing to do, but we all don't know what to do. Like we all don't know where to start. This is a good point to joining us is a good point to start. You will see how it is. And like maybe like from there, you will have your own project. So I'm going to share my screen right now. Just give me one sec. Okay. So as you can see, I am on the, sorry, give me 1 second. So I'm going to post, Karen, I'm going to post the GitHub link right here. So this is the GitHub link. So this is the Women Who Code Python GitHub link. It has has webinars and everything, all the webinars, and like if you want to go through it, feel free to do so. And if you are joining any other like future sections or future study group workshops, all the materials should be here as well. So all we have to do is to scroll down because we are on the Discover NLP with Python study group. So all we have to do is click the button, and then we will see all the materials are here. Double check. And so you have to, so this is session 4, so we're going to this link, basically the bottom of the link, but the bottom link of the list. Click here, and then it will load the notebook to you. So if I remember correctly, there's a button you can actually paste it on the GitHub. So if you can, you can put it on the collab, but if you can't, I think Rishika is sending you the direct link of the collab notebook, so you can access it there as well. If not, you can just watch me like going through it today first. Okay, so once we've done, okay, now we're doing. Okay, so if you successfully open the GitHub link, so the way to do GitHub link, you can do actually open notebook from the GitHub link. You can do that as well. So for those of you who want to join and follow through on your own computer. And then afterwards, you have to save after you open the notebook, you successfully open the notebook, we remember to save a copy in your own Google Drive to actually access it and type it. Okay, let's dive into it. So like Jasmine was saying, today we're talking about neural machine translation. Like it's a typo. So basically, neural machine translation is one of the most powerful methods right now for do natural language processing. So today we're gonna do a very introduction. We're gonna do an introduction how this gonna be done. We're gonna be using LSTM, RNN, a very popular neural network model to get it to just do the sample, like to just do the sample translation between English and Spanish. So on first week of the NLP study group, we talk about their 4 cycles. I think Jasmine like went through it as well. So there's a 4 steps to basically 4 main steps to do the machine translation. So we have to do prep the data. We have to do data pre-processing and possibly EDA, exploratory data analysis. And then because words is not readable by computer, so we have to do a second step, which is text representation and feature engineering. And so another to encode the encode, do some sequence encoding and decoding on the word and factor in order to for word to process into the neural network at the algorithm. And then the next step, we have the model. We want to have we build the model to do the translator and do the job. And then of course, after we training the model, we want to know the results, we want to plot the result, and we want to make the prediction. So these are the 4 steps that we're going to be going through. So let's go to the first one. Data pre-processing and EDA. And you will notice I will talk about more about how to prep the data instead of doing the actual model, because the actual model is, Python, the one of the nicest thing in Python is it's already built really nicely. All we have to do is add the couple level lines of code. And then data scientists or past developers should do all the algorithm for us. So you will see I will focus on way more on the first 2 parts, because it's very, very, very important to you understand how is the data is and what we're doing with it. So first of all, we're gonna, where's the data coming from? We're gonna download the data. So right now we're gonna download, you can see here, we're downloading from a website. We're downloading the English word and English and translation word in a website using a zip file. So the get download, and then afterwards we know this is a zip file. So we unzip the file. These are the terminal codes, by the way. This is not like anything with an exclamation mark. This is like a terminal command. It's not a Python code, just a little FYI. So afterwards, so we know that we have 2 files. So we unzip. So we have 2 files, and then we know this is the file we're going to be using. So before we doing that, we want to know how it looks like. None of us never seen the file, how it looks like before. So without knowing what it is, how we're going to do anything. So I have 2 lines of code to give everyone an overview on how exactly the text file looks like. So I took the first 10 lines of the text file and the last 10 lines of that file to give an overview. So you can see the pattern here. So basically the first 10 lines, you have 3 columns. So that's exactly happened to the last 10 line. So 3 columns, you can tell the first column is the English one, and the second column is the Spanish one. And the third column is it's more like a documentation. So we know that we're gonna use the first column and the second column of the text file. That's all we have to know for now. Okay, so now that we sort of have an understanding of what's going on, we basically write some Python code to load the text file and read the file as a pair, Spanish pair and English pair. So you load the file. We use this function to load the file here, and then we using this function to read it as to ask the Python read it as a pair. So just a little FYI here. If you can see this we can tell it's the 3 columns because there's a comma, there's this little space between it. There are different types of delimiters. So this is called delimiters. So there are different types of delimiters. There's space delimiter, there's comma delimiter, which is which is where exactly CSV file is from, comma separate value. Yes, common survey value. So this, in this time, I know it's tab. You just have to try it out. Just be careful. Just want you guys to pay a little attention to when you read and you process a text file, especially a text file. Is like it could be comma, it could be space, or it could be a tab. So if a tab, like we use like /t to represent it to read the lines. Just a little like FYI. So afterwards, we do it to pairs, and then like we translate it to numbers so that the computer understand it. And because the file is very big, it's very large, and like we want to save some time for to show the samples, so we're gonna take the first 100,000 lines from the text file, and then we take only the first two columns like we said before to do the English and Spanish translation. So if you take this properly, and you will, and then like you will see it here as the result. If I take the first 20 lines, you will see this is the nice pair. So basically compared to here, we don't have the third column. Afterwards, after we successfully take the data we want, like the raw data we want, like the tricky thing about machine is it treats everything equally, basically, in a world in a natural way. So having a comma there, having a punctuation there, having a space there is like is as much as important as having an alphabet there. So it's a good thing. But then when we want to train some word, it actually adds the complexity for the machine to understand what's actually mean, right? So basically in here we're gonna remove a couple of things to make the translation a little more accurate in a simpler way, and understand it a little better and all like efficient way, and it will reach you to a higher accuracy. So we remove something we wanna, because they're like, besides punctuations, printable character, that's like something, a form that like it's like for programming. So punctuation, printable characters, and numbers, and like these ones, we also try to remove some unnecessary white space, and like normalize the code, because like there are a couple ways to for machine to translate a word from a word to like a whole bunch of numbers. There are different ways. So UTF-8 is one of them. ASCII is one of them. If you never heard of it, Unicode is just a way to transform. So as you can see here, basically for here, prepare in lines, we want to, encode it. We want to like normalize it, and we encode it to ASCII, and then after we want to translate to ASCII first, and then we want to decode it through from the UTF-8. And then you can see here, we do it like we want to do everything lowercase, because lowercase and uppercase matters at all, matters so much on the computer. So we want to make it like, the simpler, the easiest way, the fastest way. So lower all the, we don't want any capital letters. We replace all the punctuation with nothing. Basically, take out all the configuration, take out all the printed characters, these ones, and then we will do line. We'll do and then like we will only take anything that is alphabet. This is what it means here. So afterwards, we add it to a new list, and then add it to the new pair, and then return as sent away. So if you can see here, the same 20 line, I will show you that's before. This is how it looks like. That is after. I kind of keep the space there to just to show, like to show the difference between the word, but you can remove it as well. So you can see this is much cleaner, much more natural way. So like from the physically point of view, like it's the machine, it does reduce the complexity compared to like what we had in here, right? Okay, so that's the part. And so before and then afterwards, so usually when it comes to very complex data, which is not in this case, it's definitely better to understand what the data has with like a very brief analysis. This is what exactly EDA means. But so that, like, different, if you have like different distribution on the data or different statistics, like you will, like, usually data scientists will have a different method to apply what to do with the word and what is the best way to train the words, because there are so many different methods to do it. So in this case, we don't really need it because it's fairly straightforward. But like, I'm going to show you guys for the purpose of it, so to understand what it is. For example, we want to understand the length of data. So in this case, basically, I use Matplotlib and pandas to do it to here, to see it here, and then like the distribution. Sorry, it's a little hard to see. I should have done it better. So basically, we can see the length of the data. Okay, so the distribution, basically, majority of data are between like five, like on the five, or on both Spanish and English. So that's how we do it. So after we do all the pre-processing, this is the first step. Second step is to making sure, it's basically making sure the machine is like we make sure we translate it to a thing that machine understands. So how we do it is we're gonna do two things. We're gonna do tokenization. We're gonna do encoding sequence. So before that, we have to split. If you've done a little bit machine learning, this is like absolutely no stranger to you. We have to split the test. You have to split the data set into training sample and testing sample here, and then so the ratio is like 7:30. You can adjust it however the way you want. But basically, it means like 70% of the data. So basically, 70K lines of data is going to be training, and 30K lines of the text file is going to be the texting one, is to see how accurate the training set is. So tokenization. So basically, we wanna, so even like there's a one word, like one term with 5 words, we want to break it down even more. So we use the method, the tokenization, to break down it into individual words. So this is how you do it. So basically, I put a tokenizer on English one and Spanish one. And you can see that, just to show you, like, this is the length of the English vocabulary, the example. After we done the coordination, we need to translate it into, like, the word into same length and a numerical form. So same length means, for example, hello and go. It makes a difference because there's 2 words and 5 words. So when machine reads it, it makes a big difference. Like I said, like every single thing that we take it as, is very common for us. It matters a lot on machine. So that's why we always have to, debug the code, because machine doesn't understand the way we understand. So we have to make sure the machine understands this is equally as important. Go and hello is equally as important. So we do encoding sequence to make sure or set the length as 8. We make sure they understand like these words, like to kind of like spread it out in numbers, to make sure understand like these are the exact same thing, like exact thing important. It's not because like these are shorter and these are longer. It's just a phrase. It's just a phrase. Don't take it too seriously on the length. It doesn't matter. So this is how we tell it down. So basically, we have to train data set, we have to test data set. We do this for each one. We do it in the Spanish one, and we do the English one, same thing. And afterward, and you can see, I will show you, this is a raw example of how it looks like. It's like the numbers, it's like a whole bunch of number. Yes, like this. We do understand, no, but the machine understand, hopefully. Okay, so now after all the processing, we finally get to the fun model, which is only like basically a 5 lines of code. So what we do is here, if you want to focus, it's only here. So basically, like I said, we are using LSTM as the fundamental machine, a neural network. You can use, if once you get a hang of it, you can mix a lot of neural network. You can mix CNN with LSTM, and they have like, even like CNN itself has like different architectures that like you can play around with, and it shows you different results. It's just like the time exploring, like, exploring time is like unlimited. Like you can do it like the whole year. You can do it for your whole life. So we're gonna use as LSTM. So basically, we tell I'm gonna read it word by word here. So we're gonna have 5 layers, like 5 layers, yeah. So basically, we set the model. We're telling the model is this is a sequential model, and then we're gonna input the model. We're gonna like this is the input layer. We're gonna input the model with the data, and then we're gonna train with LSTM, and then we're gonna repeat. We're gonna do like a repeat factor, and then we train the LSTM. It's just like similar to like for propagation and backward forward. Anyways, it's just like training back and forth. Sorry if I'm like a little bit too deep dive on this. So after we do like a back and forth for 2 LSTM, we have a dense model, basically a softmax layer, to get the max possibility. So basically, out of the all the out of the all I don't know, internet song play. I'm just making it up. Like which the word is like, is it like frustrating, or is interesting, or is hello? Like they get the highest possibility. So basically, get the most word, get the most accurate output out. This is what it means here. After we set all the 5 layers, we compile into model with like an optimizer and the loss. So optimizer, just a very quick overview, is basically how you dealing with the loss. So loss means like you will have, like, accuracy means like how accurate it is to the word, right? But loss means like how much you didn't train, like how much work, like they can't process it. So optimize it is just a little trigger to tell the model like how do you deal with these one, how do you minimize the loss, like the number of words that you cannot train. So this is what it means. If it doesn't, if it's very it's very foreign to you, it's new to you, don't worry. I think nowadays data science nowadays, they just have to understand the very brief concept of it. You don't even need to code, but like I said, like just put the 5 lines of code, try to understand what it means, and you can voila, go with it. If you don't, then try to understand the concept first. This is important, of course. And then we will start training the model. So basically, I set a checkpoint. Checkpoint means so basically, first of all, I'm saving the model in an H1 format. So it's the different types of format. And then we're gonna save the best model only. So basically, I'm training the model in 30 cycles. It's equals. So basically, like 30 cycles. So different cycle. The last one, the 29th cycle, is not necessarily mean is the best one. It could be 20. It could be 22nd. It could be 21st. So I'm asking this line. I'm asking them to save the best one, the least lost. Like this is how I'm doing it. And then here, and what you compile, you set the safe one, and then you can do it. You can fit the model. So see here. So validation split, and you can just train the model. As you can see, if you press this magic button, it's literally training, and you can see the loss is low. The loss like start going down. It's supposed to go down, but it doesn't, like I said, it doesn't mean the last is the best. Majority, like sometimes. So afterwards, after we train, like let's say let's pretend we train the model, like it takes something, even a 30 apples like takes some time. It's just to make sure that you have like more than 100 Ks of lines of text to train. It takes a lot of time. So let's pretend we done everything. So basically, I will tell you, this is like we want to load the train model. I won't be able to show you guys, unfortunately, but like I'll explain the concept. If you guys want to try, go ahead. And then we want to see the result. We want to see the loss between the training loss and the validation loss. So this is how you plot it. So just picture you have like one graph of two lines showing how it's supposed to be going down. I suppose like the both, like if you train the model properly, it's supposed to go down, both of them, and that means like you're using the correct method. If you're seeing going down, you're in the right track of the model. If not, their model is one of the things you have to look at. Also, sometimes how you prep the data is also one of the things that would matter. Afterwards, after we see the model, we pretend we see the graph. We want to make a prediction. Of course, this is the important thing. Like how else we're going to train it. So basically I use a tokenizer. Basically I use this, like I said, I use the model here. Plus plug in all the words, and then I'm gonna use the get word function to translate back like what are you getting, what are the result, and then they show it in a table form. So this is how it looks like. I like I said, I'm not able to because it's still training. But then if you guys can play with it, go ahead. So that includes all the very brief introduction of what neural machine translation is. It should be a very straightforward and like fairly simple one. So if you guys have any questions, please let me know. No, you guys are all good. You guys confused, or you guys like, oh, this is easy, expert already? All right. Okay. Thank you. Okay, so if you guys, because this is the fourth section, if you guys don't, thank you. So if you guys still confused what's going on, feel free. If you new, if you some of you are new to Python, if you're coming to this subgroup, it might be tricky. So what we recommend you to go. Okay, Karen asked a question. Very, very, very great one. And I can tell you, this is the question every single data scientist has been doing it. So Karen has a question of how do you decide which loss function to use of each model problem? I'm so sorry to tell you there's no best way. Even myself, I'm a programmer. My boss is telling me, when I asked him this question, he said like you have to keep trying. You just have to keep trying because different even you have the very similar data set with like the exact same approach, and on that model, on that experiment, you on that model you got 90% accuracy results. And like if you have the different data set with the exact same exact same model, it just varies. It's just not happening. And then like you just have to keep trying, like there's no best way. So this is the nice thing about machine learning, like artificial intelligence in general. You just have to do you just have to keep trying until you yourself figure out what is the best. There are a lot of there's a lot of method like people try. There's a lot of people that there's a lot of like methodologies and architecture people try that they think is the best suitable, but it doesn't work. So sometimes it doesn't work on your data set. So if you want to you just have to keep trying. But like if you're reading, oh, sorry, actually, would you want to take this question? Would you mind taking this question actually?
Yeah, sure. Hi,
There
Karen.
you go.
Yeah. So for loss functions, right, it depends on which sort of work or what are you trying to do. Basically, in machine learning, either we're doing regression or we are actually trying to predict something via using, accuracy metrics. So that is where the loss function comes into play. I think here you're doing regression, right? Or are you doing? Yes. Can you go down? No, no, go down. Yeah. So here, yeah, you're doing accuracy. So yeah, you're actually importing a model and you're importing the accuracy score. So out here, you're calculating the accuracy involved. So like that, you decide based on what you're trying to do, the loss function. So for example, you're doing regression, you might use mean absolute error function or mean square error function. And otherwise, you can also use accuracy when you're trying to predict a model, and that is, for example, for classification. And what Karen is talking about can also be done. It's called much more in the hyperparameter tuning. What that means is there are certain parameters in the model that is tuned according to the data you have. So it's a lot more dependent on the data you basically have. So there's no one way of doing it. The only way to do it is to acquire data, understand it, and then tune it. So that is what is the major difference. And yes, you need to sort of do a lot of train a lot of models and train a lot of models on dirty data to understand how to tune the right hyperparameters. But yeah, I hope that answers your question.
Thank you, Ashina. Thank you for answering the question. Karen, hope that answered your question. Any other questions? Any other general? It doesn't need to be specific to the hype to NLP. I mean, like it doesn't need to be like specific to this section. We have Ashina here. Who's definitely doing machine learning for sure. And then I'm the newbie here. And then you have Rishika is learning machine learning as well. And like if you have any questions, anything, like let us know, and then we will answer you as best as we can. Okay, Uma, you asking the right question. You're asking the right person. Good. So Uma is new. So if you don't mind, if I will read your question out loud because I think it will apply. It could apply to other people as well. So basically, you know some basics of Python, and then you're very much interested in coding. So I'm glad that it gives you it gave you some confidence after seeing the section. So the link of learning the business coding is to go to the GitHub link that we share of the Women Who Code Python. Me, Rishika, and Stephanie, and Ashton here, we just did a beginner Python study group. So if you want to, refresh your memory of coding, if you've done something, you want to enhance it, like make it more confident, feel free to check it out. I'm promoting my own study group here. So feel free to check it out. It's called Beginner. So like I said, it's on the same GitHub link. It's called Beginner Python Study Group. At the same time, if you have the question, yes, Stephanie posted in here. Stephanie, so you can follow it there. So if you go to, we done like 8 sections, a 7 session minus the review section. We went to some basics. So if you want to go through it, feel free. If you have any questions, please let us know on the Slack, and we will join us on Slack if you're not on Slack, and then we will definitely helping you answer some questions. And so Karen has a question: how do you get into data science? Maybe Rishika and Ashna can join and chip in here as well after maybe my turn to answer. So I am from data analyst. I'm from a data analytics background. Actually, I start Python with literally data processing, data quality. That's why you see me talking so much about data processing, because that's what I was being focusing on. I get into data science mostly because of my job. I just got a job into deep learning. I'm doing some deep learning projects, like more like a classification. So that's how I really got into it. I mean, like it's a different field, but like because I've been using Python in like data analytics and machine learning. I'm having fun learning different things with Python for sure. Ashna, Rishika, do you want to share your experience as well?
Yeah, I can go first. Hi everyone. As Karen said, I also came like her. I also came from a different background. I am not into data science in particular. I've come much more from a electrical and an electronics background. So I started using data science because I found the fact that we had quite a huge amount of untapped data in the field of electrical systems and power systems as such, which weren't used a couple years back to an effective way in terms of understanding data and drawing conclusions from it. So that's when I started using data science as such. And I think one of the best facts about data science is that it's so widely used. You don't necessarily need to change your fields completely in order to learn it. You can learn it as a skill and end up using that skill into your field too, which is exactly what I do right now. So I still work around embedded systems and microcontrollers. I just use machine learning or deep learning models and deploy it on these systems. So yeah, that's pretty much it. But I would love to hear Rishika's journey too.
Yeah, for me, I also originally came from I'm still in the STEM field, but more in psychology and biology and neuroscience and sort of in the more medical field. And then sort of switched over and was just curious about programming and computer science. And so my first sort of step into it was just starting out with Python, like a sort of like a free course that I found online. It was actually through MIT Open Courseware. I highly recommend that. It's completely free, and it's like basically old MIT lectures with like provided lecture recordings and assignments and all of that. So kind of use that to just sort of get my feet wet and see kind of is this something that's interesting to me. And then I took a couple gap years to take some more courses also in Java and C++ and data structures and algorithms. And then I also had an internship as a data science intern at sort of a medical device company. So that was really interesting. That was like sort of my first real world exposure to data science. And I think it's just like data is fascinating and what all you can do with it. And then, so now I'm in my second year of a master's program in computer science, and I have a concentration in artificial intelligence and machine learning. So, data science kind of goes hand in hand with both of those. And constantly working with data for the research I'm doing also as a graduate student. So yeah, I think data science is definitely something that you can sort of get into, whether or not you're, initially in computer science or programming, and it's kind of a nice intersection of a lot of different things, and you can apply data science to so many other fields, fintech or medical or healthcare, or anything you can imagine. Um, yeah, that's a little bit about my experience.
Thank you, Rishika and Shana. Jasmine, I know you're learning. You're definitely learning with Python and data science. Any tips and any tricks and tips that you want to share with the audience that find it find it useful?
I think like when I started, I was more read and just practice coding every day. I think that helps. Uh, Contributing to open source, that's one of the like very good areas that I feel you can grow. Like small contributions, like going and just editing a SQL code, or going and editing changing their Python logic or something. So that's helpful. Open source is really good.
I agree. Thank you, Jasmine. Um, okay, I think we are good here. Rishika, would you wanna do the closing?
Yeah, sure. Or Jasmine, I'm not sure if you were prepared to sort of do the recap and next steps.
Yeah, I can do it.
Sorry. Yeah, sorry, go ahead.
Okay, no, you're good.
Okay, so just to do a recap, for today's session, we spoke about what machine translation is, the brief history of machine translation, different types of machine translation systems. That's rule-based, statistical, neural, and how neural machine translation makes for a faster translation than the other methods. We also went through the sequence to sequence models, and with the two main components, encoder and decoder. So that concludes all the content for today's session. Here is some upcoming event that we have. You can find this on Women Who Code Python website. And please stay connected with us. We are on all social media, on Instagram, Twitter, LinkedIn, and also you can find our Python website below. If you have any questions, feel free to drop in a Q&A box, or you can also join our Slack channel, which is Discover NLP with Python. Do you have any more questions?
Uh, Moya has a great question. I'm not in the field. Is Ashna or Rishika interested taking to the question that Moya has? By any chance?
Even I am not from the same field, especially like in the gaming scenario, like where you were using AR VR. But I can do a little digging. You can reach out to me on Slack. I can do a little digging and find out if there are any good courses. I would suggest, since everyone is on, the online right now, I would suggest going on to some courses online. That really helps to understand where to start from, and I can find out a little which courses are good. And you can reach out to me on Slack, and yeah, I'll text you some good courses on this.
Awesome. Thank you.
All right, I don't see any more questions in the chat or in the Q&A, so I think we're good to go. Yeah, thank you everyone for joining. So this is our fourth and final session for the series. Thank you to everyone who joined in today. Feel free to see what other upcoming events we have, as well as like links to social media and everything else. It's Stephanie provided that in the chat. That's just our Women Who Code website specific to the Python track. Yeah, I just want to wish everyone happy holidays, and I hope you're all staying safe and healthy. And yeah, I guess that's it for today's session. Thank you, everyone. And Jasmeen and Karen, you both did amazing. And so happy that we had both of you to sort of close out the series for today. You guys are amazing.
Our pleasure. Our pleasure. Our pleasure. Okay.
All
Happy
right.
holidays, everybody.
Yeah, happy holidays, everyone. Thanks for joining.
See you
Well,
guys. Join us in our next workshops soon.
yeah.
Next year. Okay.
All
Bye,
right. Thanks,
everyone.
everyone. Bye.